Okay, now we proceed with the undamped free vibration. So duha man ni siya, there is the damped and undamped free vibration. So after that, you will be able to differentiate and say kalainan nilang duha. Okay, so for this topic, we will use the spring mass system, which is actually also part yapon ni siya sa kaning feedback and control system. Makita gyapon ninyo ubalik. But for undamped, there is the no influence of external forces or excitation, so that's why it's called undamped, no? So it's free vibration or oscillation. Sabot niya na ay cycle na yung oscillation good. Using the application of Newton's law of acceleration, muna itong gamiton din and then we will formulate the differential equation that describes the simple harmonic motion nga gi-generate aning ato ang spring. We will obtain the solution which represents the response of the vibrating system. So kanang nga response is called the position of the object. So from here, no, or mass at any time, or velocity or acceleration. Ato na siyang matagsa-tagsa discuss. We will also study the parameters related to simple harmonic motion like amplitude, frequency, and understand the factors that affect them. Okay, so this topic is also important and fundamental in the study of dynamic and control systems. So by definition, ang simple harmonic motion is a type of periodic motion in which the acceleration of the object is always proportional. Muni iyahang pasabot o. The acceleration is always proportional with the displacement but is directed in the opposite direction. So gutay-gutayo na to niyon si pasabot niya, no? So here, based on that definition for simple harmonic motion, ang acceleration is opposite sa displacement. So just like this spring, the spring ka ba, di ba kung in actual setting, kung ato ning birahon ang spring paubos, ang iyahang ano na siya certain displacement. And so, pero iyang force asa man padulong, opposite, no? Baliktad, which is mo ni siya, the spring force. It pulls upward. Kung inani ang ato ang spring, no? Vertical siya. Inigbira na to, na siya spring force nga opposite. So, muni kibali ang iyahang theory, which is under the simple harmonic motion. So acceleration is directly proportional to displacement, only that it is in the opposite direction, so negative siya. So kung ato ni siyang kuha butangan og proportionality constant to eliminate this proportionality sign, so mo ni atong ipuli the angular frequency, which is omega naught. Actually this is omega naught here, but it's still omega, which is also very useful sa ato ang next nga mga lesson sa communications, also sa nagyapon siya sa physics, yeah. And so if mo ni ato ang spring, no, so kani siyang sa left side, mura ni siya og ako ang gi-represent nga nilihok ang spring, no, gibira. So the initial velocity usually 0 ba na siya, no, ikaw ra may nagbira or naay ang iyahang opposing force is the spring force. So we have here a certain mass, so we have to be careful with the units, no, naka-SI unit ni siya, meaning naka kilograms. So kung ang given is in grams, it should be converted into kilograms. Ang meter, kung nigamit kag centimeter, it should be converted to cm. Ay ka mag-substitute. So manay common mistake sa uban na mag-solve na kay diretso ra dayon, no? So we have a mass here tied to a spring nga naa siya diri pa vertical, no? Then K here is the stiffness, which is the spring constant, that is in Newton per meter. Okay, now our Fs here, or the spring force, mo ni ang giingon nga here, I noted here that F of S is headed towards the equilibrium position. So, unsa pasabot sa equilibrium position? So, sa iyang initial position, mauni, no? I placed here kaning naka-equilibrium siya, meaning mauni iyahang zero force exerted, zero displacement exerted. So, every time mo palayo siya ani, mo exert siya opposite force, no? If the displacement is going up, ang spring force is going down. So inana na siya, no? And then it's also called the restoring force kay moadto jud na siya padulong sa iyahang equilibrium position, which is diri, no? So Hooke's law states that the spring force is always inversely or directly proportional to the negative displacement. So muna siya ang simple harmonic motion nga theory. So our f of s here is equal to negative kx. So muna siya usually nga given basta sa spring na jud na siya k, which is stiffness, and it's always negative because the spring force is always opposite to the displacement. Okay, now for its amplitude, as it moves up and down, akong i-explain ganina nga kung magsaka goes up, goes down, or goes left, goes right, opposite to, no? It will reach at a maximum displacement and reach the until it reach the equilibrium position. This maximum displacement is identified as the amplitude, or displacement is the amplitude of vibration, like the maximum displacement of the mass. So how do we generate a dE from here, no? So we use the Newton's second law of motion, which is the net force is equal to acting on a body is equal to mass times acceleration. So gamit gyapon kay na diri. So looking at this example, no, para sa ato ang explanation, mo gyapon ni. Then our net force here is the kaning k times the displacement x. Okay? Now, matingalan mo nung na a unsay difference sa a ug sa x. You will see it unsay kalainan na ug asa na siya gikan. Actually, amplitude is part of this displacement. No. So using the second law of motion, mo ni siya, no? We have this, which is equal to negative kx equal to mass times acceleration, where our acceleration is the second derivative of x, which is the displacement. Ang first derivative niya is the velocity. Okay? So muna siya iyahang kuan, or x double dot. A is equal to x double dot, or the second derivative of x, which is the x of t, which is the displacement. Okay, so we rewrite this equation using the standard form of HLCCDE. Kay from here, kung ato ni siyang substitute diri x double dot, then rewrite, rearranges the equation to make it the standard form. This becomes m times double dot plus kx equal to 0. So this k over m, if you look at the standard form that we had in the prior slides or prior nga video, the we can let k over m as d omega naught squared. Now this is standard form, no? So this becomes x double dot plus omega naught squared times x equal to 0. So this is now homogeneous. Now from this equation, differential equation, we can now generate the general solution. Okay, now the general solution for this one sa inaning case is kini nganuman, this omega naught squared ato ni siyang kuhaan sa, or this equation ato siyang kuhaan og auxiliary equation. So we need to find the roots, di ba? Ang roots, regardless, di ba, remember for the roots we have 3 cases, no? One is katong the roots becomes the exponent of the exponential. Second is the repeated roots, and the third is for the imaginary. So in this case, we can substitute or let r, no, not x, because x can be misunderstood. Kay here x is the displacement, so we can use r. So wala ni siya significant nga kuan ha. R is just represents a variable para atong makuhaan og kuan dili m, because we have m here as mass, not x, because x here is displacement. So r squared lang, or r lang. So sa roots we can have like r squared plus omega squared equal to 0, in which the roots is actually plus minus omega naught I, or imaginary. Now from this kuan, kaning result of the roots, naa naman na siya pre-discussed na to nga form of the general solution if this is our root. So, mo naman ni siya. Okay? Diba? Now, this is actually the general solution for the displacement. Mo ni siya. But we need to find the C1 and C2 because this, or actual value of C1 and C2 because this is actually insignificant. We can replace it with more useful parameter, which is for C1 and C2. More useful parameter is the amplitude and the phase. So, unsa man na siya. So, remember, we have the initial conditions nga we can set initial conditions at initial position. So, displacement is wala pa siya naglihok. So, x is equal to 0. And then, the second derivative, or the first derivative of x, or the displacement is the velocity, which is, initial velocity is still 0. So, we can use both to find C1 and C2. Okay? And so, we can rewrite then the x of t in the phase form. Muna akong ipasabot kanina, more useful for C1 and C2. Okay, let's proceed to the next slide, which must na demonstrate ni siya. Okay, so we have, we will introduce here terms like amplitude, phase, frequency, and period. So, mo make sense na ni siya when you go to communications subject, you proceed with circuit theory subjects. So, mo na ni iyahang unsay connection sa Newton's law of motion in generating a DE. And then now, nagrepresent di ay siya og specific amplitude, specific phase, frequency, and period. Okay? So, meaning, paglihok sa spring, nang manggawas ni sila. So, we rewrite the kaning general solution that we come up earlier. So, mo ni siya, no? And then, we express this in amplitude. So, how do we arrive at this equivalent form? Okay? So, this actually this A actually is the amplitude. Yun sa pagkuha ang amplitude, gadepend gihapon siya sa ato ang initial condition. So, mo ni conclusion din hi. So, this amplitude has the formula of coefficient of cosine squared and plus coefficient of sine squared, which is C2. Wala siyang Pythagorean. So, that is the amplitude. Square root of C1 squared, square root of C1 squared plus C2 squared. That is the amplitude. And then the phase, or shall we say the sabi other term, ano, phase constant or phase angle, tangent inverse of C1 over C2, or the coefficient of sine over the coefficient of cosine. So, both are dependent with the initial condition. Kaya nga naman, di man ta makakuha, dito man ta magkuha og value sa C1 ug C2. So, how do we get that C1 and C2? Earlier, we had this kanisiya, maman niya itong x of t, the displacement, no? So, ang initial condition na to will be this kani. So, we can substitute x equal to 0 at t equal to 0 from this equation. So, makakuha ta og C1 or C2 here, 0 dire. And then this x dot is the velocity. Ato sa ni siyang i-differentiate. So, just like what we are doing with HLCCDE. No? Pag-differentiate ta, so we can substitute this. And so, man nato pag-substitute kung wala ka nag-derive, kaya naaman ni iyang value. This is x dot equal to 0 at t equal to 0. Then, we come up with a C1 and C2 value. Ay, hanaday natin siya i-rewrite into this form. So, this A here is the amplitude over the vibration, and the phi here is the phase angle or phase constant. Okay, again, both are dependent in the initial conditions given sa problem. Una. Okay, now, another important parameter is the angular velocity, which is the omega naught. Okay, kung in this waveform, ato nang discuss ang asa ni sila napitang nga butang. Okay? Now, the angular velocity is expressed, or its unit is radians per second. So, remember earlier, our omega naught squared is equal to k over m. So, from that, equation, we can have angular velocity equal to the square root of k over m, which is angular velocity is always equal to 2 pi f naught, or the natural frequency. Okay, so therefore ang atoang natural frequency of the vibration is equal to 1 over 2 pi k over m, whose unit is in hertz. Okay, hertz siya. Okay, and then the inverse of natural frequency is the period. So period of motion, which is equal to t nga dako. Okay, t nga dako, period. And then this t is equal to, if we're looking at this equivalent formula, we can have t equal to 2 pi times the square root of m over k. So this is in seconds. Okay, period man, time man gyapon siya. Okay, so in this graph here, or sine wave representation, kay kani ato ang kuan is sine wave man ni siya. So atong gi-graph diri, there is this offset, no? Wala siya nag-start. Usually, di ba, mag-ana man na atong graph, no? Mag-start man dyan na sa 0. But this one, if you notice, gana ay negative diri. Oh. Anong negative ba na siya? Ang nagbutaan man ito na negative din na, buot ako, no? So, kung imo ni siyang i-derive, muna mo actually yung equivalent. But here, kung ato ni siyang i-graph, there's a negative offset of phase because or kani yung equivalent value sa phase angle na medyo offset siya. Kay negative man siya diri, no? So offset siya from t equal to 0, which is nasa origin, and then yung representation ani pasabot ani is advance ang imong signal ni, advance siya og pila ka phase angle. If nag-una siya or nasa sa left, dili pasabot nga negative man ni diri no sa axis. Ana, negative to. Kung nag-una siya diri, advance na siya. Okay? So, if diri po siya dapit paingon sa right, this is delay, no? Delay. So, actually, kani sayop ni. This is negative. And this is positive. Positive siya in a sense nga, positive siya diri, no? There is a sign. But, in the actual, diri siya mag-start sa positive side, which is a delay. If it's on the left side of the axis mag-start, no? So this is advance ni siya. And also in this representation, you will see the amplitude, which is the peak value of the sine wave, no? Peak value ni siya. So if this is our displacement, ang iyang peak value is mao ni, no? Sa vibration, unsa siya kataas sa iyang waveform, ang pinakataas mo na iyang amplitude, and usa ka cycle of this wave is period. Okay, so mani iyang representation ani. So do not forget these formula, kay discuss na nato ni yun sa ni siya pag-come up from this solution, no? This is the general solution that we have. So muna siya significance sa general solution for actual application. And then the amplitude, the phase, we have angular frequency, and then we have the period, we have the natural frequency. Importante na sila ang mga formula sa mga problems nga atong i-tackle in the from here on. Okay, so we also have the terms velocity and acceleration, no? Ang velocity, as I mentioned earlier, is the derivative of x, or displacement with respect to time. So this is dx over dt equal to v of t. Then acceleration is the derivative of velocity, or the second derivative of displacement, which is only yung equivalent. If we have that x of t earlier equal to a cosine omega naught t minus phi. So kung i-derive ni mo ni siya, v of t, here nara, if ato na siyang i-derive, muna ni siya. Actually, hugaw-hugawan. Okay, this is the first derivative of x of t, and the second derivative of gini. This is the value no? And so unsa man ang atuang maximum velocity and maximum nga acceleration. So when you look at the amplitude lang, yan ninyo makita ang ito ang maximum velocity. So this actually not at, but at sine, any value of sine which is equal to 1, pwede na siya, but any sine something, it should be something equal to 1. So talungan na to, no? So any sine something, what is sine something that is equal to 1? Sine something equal to 1, then this is our maximum velocity from here, no? If this is equal to 1, our maximum velocity is only siya amplitude lang, not including the sine. Also with acceleration, maximum acceleration is at cosine something equal to 1. So mo ni imong maximum velocity. So if the direction is away from x equal to 0, so makita niyo diri, if x is equal to 0 diri, is layo siya, meaning hinay ang ato ang velocity. So tanawon ninyo opposite, no? So if the direction is towards x, it speeds up. So muna iyang indication diri, the maximum velocity o 0 ang ato ang displacement. Okay, so mo siya opposite. Whereas sa acceleration, ang acceleration is sabay sa displacement. So kung ato ni graph acceleration diri, similar siya ug representation sa atong displacement. Okay, now we go to the example for undamped free vibration. Now it goes, a 10 kilogram mass is connected to a spring with a stiffness K. So naatay mass nga 10 kilograms. So this is okay, kilograms. We have a stiffness K equal to 360 Newton per meter, and the mass initially displaced, so at initial displacement of 50 cm. Cm is in centimeters, so 0.5 ni siya. So our x at t equal to 0 is 0.5 meters, diba? And then it says at to the right, the vesicular position, it was released from rest. So the initial velocity is 0. Released from rest, good, and starts to oscillate against a frictionless surface. So this is your hint that this is an undamped or undamped free vibration, kay frictionless. And so first we need to formulate the differential equation that describes the motion of the mass. So again, with the dE of motion, we have for letter A, we have the dE of motion is x double dot plus, from the standard form sata. From the standard form, we have x double dot. So muna itong gipang derive man good ganina. Ay my god, sayop. So it should be m times double dot plus kx. Diba mo man ni atong nakuha nga from the vertical nga spring with a mass sa ubos, mo man ni ato na generate, and so we will write this in the standard form, which is, and then ato sa siyang substitute po diri. Then we have x double dot, mo na ni atong actual equation, plus k over m, which is 360 over 10, that is 36 k x equal to 0. Okay, so this is our dE. So muna siya ang sa answer, no? Muna yung answer sa atong letter A. Formulate the dE that describes the motion of the mass. Muna siya. Okay, now sa letter B, we find the position, velocity, and acceleration of the mass at any given time. So we need to do the find the general solution. So ang answer ani is the general solution. So which go to letter B. So from A, which is our DE, we need to find the auxiliary equation. So just like LCCDE, mo gyap ng process. Only that we need to find first the DE from the given word problem. Mao lang na nakalahi niya. And so we have here for the mass, this is m squared plus 36 equal to 0. So nakuha na, hindi na ta mag-agig D because D here is actually D squared plus 36y. Diba? Ano man na siya, and then mag-m din ka ani. So m squared plus 6. So our roots is actually plus minus is equal to plus minus 6i. Ayan. Meaning, this is sinusoidal. Diba? Kay imaginary man. No? So, from this one, na formula, this is actually the omega naught na. No? So, our general solution is x of t equal to c1 cosine omega naught is 6. So, this is 6t plus c2 sine 6t. Oh. So, this is now our position. Let's look for the velocity. So, our velocity is the first derivative. So, our v of t is equal to negative 6 c1 sine 6t. Ba, ang derivative sa cosine is negative sine. So, muna negative siya. Plus 6 c2 cosine 6t. Now, we have two equations na. And then, we can have, we can substitute the initial conditions. Kani? No? We have given displacement at t equal to 0, x is 0.5. At velocity at rest na siya, t at t equal to 0. So, we can use this here. No? Use initial conditions given to find C1 and C2 na. So, here, actually, ang atong C1 and C2 is 0.5 and C2 equal to 0. So, you can do that on your own. Substitute na yung 0 and then do the math. Then, our new x, t, is now equal to 0.5 cosine 60. Okay? This is the actual nga position. Okay? Ang ipangita sa atong problem. Kulang pa ni siya kay nako may arbitrary constant. Okay? So, what is the velocity? So, the velocity is first derivative. This is negative 3. 6 times 0.5 is 3 sine 60. And then the acceleration is derivative ani. This is negative 18 cosine 60. So this is the velocity and this is the acceleration. Oh, diba? Muna siyang ipangita sa letter B. It says here, letter C, find the position. So find the position. Find the position, velocity, and acceleration of the mass at t equal to 3 seconds. So, using the equation that we have in letter B, we can set at C, no? At t equal to 3. Okay? So, our position now is equal to 0.33 meters. Our velocity at 3 is equal to negative 3 sine 6 times 3, 18. That is, actually, kung inyo na siya i-calculator, that is 225 meters per second. And our acceleration is equal to negative 18 times cosine 18. That is negative 11.88 meter per second squared. So, muna siya. No? Mura ni siya sa number 3. Letter C. Then for letter D, it was asking for determine the amplitude and period of oscillation. So, ang inyong ipangayo sa letter D is the period. T. Diba? So, this T's formula, ganina, we're able to derive from natural frequency 2 pi square root of m over k. Bitch na. Okay, so this is 2 pi times square root of 10 over 360. So, T is actually, this is 36,612 pi, that is 1 over 12 pi, that is pi over 3. Or 1.047 seconds. Then, for letter E, nangayo siya sa what is the maximum velocity and acceleration of the mass. Earlier, I also mentioned ang maximum velocity and acceleration is at any sine something equal to 1 and cosine something equal to 1. But basically, if you look at the amplitude, mauna to siya. So, Vmax is actually kani. This one. So, Vmax is equal to 3 meters per second. Positive or negative, the amplitude is direction naman ang negative. And then our A is equal to 18 meters per second squared. Okay, very simple.